What if we increase the Earth's mass and make the Sun orbit the Earth? Let's see what would happen to the entire solar system. To make the Sun Earth's satellite, the core is shifting the common center of mass of the Earth-Sun system. It needs to fall inside Earth itself. That means boosting Earth's mass to 140,000 times its current size, which is 43% of the Sun's mass. Okay, let's crank up Earth's mass right now. Whoa! The second we hit start, Earth collapses in on itself. Surface gravity surges to 140,000 times what it is now. Rocks and oceans get crushed into plasma, and the core temperature spikes above 100 million degrees Celsius. That's enough to trigger hydrogen fusion. Earth transforms from a planet into a red dwarf star, starting to glow and radiate heat. Whoa, the entire solar system's stability is completely shattered. The Sun and Earth begin orbiting each other, and the Sun gets slowly torn apart. Earth's intense gravity strips gas from the Sun's surface, forming an accretion disk around our planet. The Sun's fusion balance is destroyed. It might erupt with frequent flare eruptions or enter the red giant phase ahead of schedule. Well, the solar system's planetary order falls apart entirely. Planets like Jupiter and Venus break free one after another, most likely becoming rogue planets drifting through space. The original structure of the solar system is gone for good. What would happen if Earth and Mercury swapped places? Alright, let's move Earth to orbit the Sun at a distance of 58 million kilometers. Whoa, in that case, the intensity of solar radiation would jump to more than 6 times its original level, and the surface temperature would quickly soar above 100 degrees Celsius. Most oceans and lakes would evaporate, leaving behind dry salt crusts, and the continents would become connected as one. Meanwhile, the extreme heat accelerates atmospheric molecular motion. Earth's dense nitrogen-oxygen atmosphere would be completely blown away within a century, escaping into space entirely. In the end, only an extremely thin atmosphere composed of rock volatiles would remain. Deprived of water and atmospheric protection, the surface would be exposed to intense ultraviolet radiation and solar wind. All plants and animals would perish from extreme heat and dehydration within hours to days, leaving Earth a rocky desert similar to Mercury. As for Mercury, moving to Earth's orbit 150 million kilometers from the Sun would significantly improve its environment, but not nearly enough to become a cradle of life. Lacking an atmosphere to regulate temperature, the dayside temperature could drop to a range of 0 to 100 degrees Celsius, while the nightside would plummet below -100 degrees Celsius. Water ice stored in the planet's permanently shadowed polar regions would begin to sublimate. However, Mercury's mass is only 5.5% that of Earth, far too small to generate sufficient gravity to effectively trap these gases and form a stable atmosphere. The sublimated gases would quickly escape into space or recondense in colder regions. Without a thick atmosphere, there would be no greenhouse effect, no stable liquid water, and no radiation protection. In the end, Mercury would resemble an enlarged version of the Moon. Lifeless, covered in craters, with an eternally black sky. What would happen if Deimos collided with Earth? Just imagine. One early morning, you look up and spot an extra tiny star on the horizon. That's Deimos, hurtling straight toward our planet. At the exact moment of impact, this celestial body, a mere 12 kilometers wide, unleashes energy equivalent to 280 million tons of TNT. While that's far greater than the combined yield of all nuclear weapons on Earth, it's only 1/3 the power of the impact that wiped out the dinosaurs. A shockwave spreads outward at supersonic speed, obliterating all surface structures within a 200-kilometer radius. It also triggers an initial tsunami wave hundreds of meters high that sweeps across coastlines worldwide, submerging low-lying areas, and turning the dream of an inland sea in Australia into a reality. The impact-induced earthquake could reach a magnitude of 9 or higher on the Richter scale, sparking a global chain reaction of geological activity. Volcanoes will awaken, and the ejected dust will form a black curtain, blocking out sunlight for months on end. What's more, the carbon and sulfur contained in this carbonaceous asteroid will produce massive amounts of carbon dioxide and sulfur dioxide, worsening acid rain and the greenhouse effect. At the same time, dust in the stratosphere will block 90% of sunlight. The halt of photosynthesis will lead to a collapse of the food chain, and massive marine life die-offs will occur due to ocean acidification and oxygen depletion. Well, surprisingly enough, the probability of life existing only drops to 85%. It seems that compared to extreme celestial impacts, a Deimos collision would be nothing more than a local storm. What would happen if we removed all other planets in the solar system, leaving only Earth? Okay, let's make it happen. Neptune, gone. Uranus, gone. Saturn and Jupiter, gone. Wipe them all out. Once the deletion is done, let's set this system in motion. Whoa, the asteroid belt in the solar system immediately falls into a state of leaderless chaos. Under the Sun's gravity, celestial bodies in the asteroid belt and the Kuiper belt start orbiting the Sun. This drastically raises the risk of Earth being hit by asteroids. We really miss Jupiter, the big brother of the solar system. With a mass 318 times that of Earth, it acts like a massive gravitational fishing net, catching over 90% of the asteroids heading toward the inner solar system. Now, without it, there are 1 million space cannonballs. Asteroids over 1 kilometer in diameter, just in the asteroid belt. One wrong move, and they could crash into Earth, repeating the extinction of the dinosaurs. This would trigger global wildfires, dust clouds blocking sunlight, massive plant die-offs, and broken food chains. Such impacts might occur once every decade. Well, even scarier, Earth would lose its orbital stabilizers. Originally, the gravity of planets like Saturn and Uranus acted like weights on either side of a scale, keeping Earth in a stable orbit around the Sun. But without them, Earth's orbit would be like a runaway horse, sometimes getting too close to the Sun, making the equator hot enough to fry eggs, sometimes drifting too far, causing the Arctic ice sheet to spread all the way to the Yangtze River basin. You might even leave home in a short-sleeve shirt in the morning and need a down jacket by noon. The only silver lining is that the moon won't leave us. Its orbit is mainly maintained by Earth's gravity, with other planets having barely any impact. From now on, we can still watch the moon's phases, and the tides by the sea will remain regular. But this small comfort won't stop the collapse of the ecosystem. Plants and animals won't have time to adapt to frequent extreme climate changes, vanishing one by one from Earth. In the end, only the microbes that can survive extreme environments, like those around deep-sea hydrothermal vents, might remain. What would happen if we replaced Jupiter with HD 100546b, one of the largest known planets? Well, HD 100546b is currently one of the largest exoplanets by volume known to us, classified as a super-Jupiter, with a mass roughly 7 times that of Jupiter. However, this planet isn't available in the simulator, so let's just transform Jupiter into HD 100546b directly. Wow, the moment the transformation was complete, the moons around Jupiter crashed into it one after another, and huge shockwaves rippled across the surface of this super-Jupiter. Callisto was even torn apart directly by Jupiter's immense gravity. The orbits of the other moons also became chaotic and disorganized. They seem bound to be either swallowed or torn apart by it sooner or later. Some of the debris would be flung into the inner solar system, becoming celestial projectiles that hit Earth. At the same time, it would disturb the asteroid belt and the Kuiper belt, causing hundreds of millions of asteroids and comets to break out of their orbits and rush inward. The probability of Earth being hit by an impactor over 10 kilometers in diameter would increase by 10,000 times, equivalent to the continuous occurrence of dinosaur extinction-level disasters. Even more terrifyingly, HD 100546b is a hot Jupiter. With surface temperatures ranging from 600 to 1000 degrees Celsius, it constantly emits infrared radiation outward. You can imagine it as a giant oven placed 780 million kilometers away. Earth's atmosphere would gradually be heated up. Half a month later, the temperature on your balcony could soar to 100 degrees Celsius, and even if you step outside for just 1 second in the sun, your skin would be burned by ultraviolet rays.